Hello there, everybody. Today we'll be doing find maximum in stack in O of 1 without using an additional stack. So what we mean by that, here is an example. So let's say we push a 2 into a stack, right? Let's say this is a stack. We have a 2. When we find the max, we're supposed to return 2. Now we push 6 into the stack, we return max, we return a 6. Now that we pop the 6, we return max, we return the 2. As suggested by this output. So how do we do this in O of 1? What are the constraints? And what can we do? So one constraint is that we have O of 1. So we can use only one stack to do this problem. Okay, so that's one constraint. So also that means that we can only use our space time complexity is only one stack. So space is O of n items, but only one stack. Time must be O of 1 to get the max item. Okay, so the first thought that one might have is what type of values can you put in? Can you put in negative values, positive values, zeros? Would that make any difference? Probably not. No difference there. What happens when you try to find the max when there's nothing in it? Yeah, that should be an edge case. I think we should return -1, but that's not right. We should return none. I think that's the right thing to do. We should just return none. There is no number in there, so we're going to return none. So that's going to happen. And with that, I think we've done with the edge cases. So this is the happy case. And this is the edge case. Edge case is just find max, right? Okay, so with that, we are done with our understanding. So let's get to our match. So the match is, I presume that we're using a stack. I love how we're doing this in opposite order, so we don't have to we're switching it up now. So basically what I mean is that we're gonna start doing umpire upside down. So we push the understanding down and then we can just stay on this screen and have the match available to us. So this is all going to be all commented out now. Okay, match. We're gonna use a stack. Just straight up one stack. Okay? So the plan, what is the plan? The plan is to include more information into the stack. So how are we going to do that? That means that we can use a tuple to store the current max and value in stack. So when we return find max, we can return the current max in stack, and when we return when we pop, we can return the value, and so we have both items. So let's implement it then. Of course, this has to be a, what do you call that? Commented out. So we're gonna do a my stack, right? Oh, this is a class, my bad. We'll call it my stack, and then we'll create a definition, an init function, and self, right? And what are we gonna do? What are we gonna do? Well, we're just gonna create a stack. So self dot stack is equal to empty. And let's create some functions. Let's say push. We have a self, we have an x, self stack dot append x. Done. We do need a pop. Done. Okay, we do need a item to find max, and that's going to return a self.stack at, like, let's say the most recent item, and let's call the second part of the item our max, and the first part our value. Or we could ask for our value and our max. What I mean by that is we're going to be storing tuples of our max value and our value. So let's just go with 0. A way we could get around the comments is to create a brand new class that uses a max value and a value, and store 2 ints. But I think with this we're fine. Okay, so with that, we're appending x. That x is a tuple. Okay, so when we push, we don't just append 2, we don't just append x, we append x and the max value between so stack at -1 and 0. So what we're appending here is we're going to append the max value between our previous max and our current item. And with that, we will be able to append the max value. We will also need to pop. When we do pop, we need to return, right? So we need to return an int. So that int that we're returning, so we have max value and current value, and that's going to be equal to this pop, and we're going to return the current value. Perfect. With that, we are good to go. Yeah, let's do it. So let's run this these cases here. We're going to return this when we find max. It's an int. And copy. We're doing a review now. Okay. In my mind, currently, we have, this works perfectly fine. So let's create our stack. We're going to do a dot push. We're going to dot find max. We're going to do a push. We're going to find max. We're going to do a pop. And we're going to do a find max. Okay, so with that, we should be good to go. One thing we do need to do is do a print statement on this. One thing we can do is to print it and then return it. But how goes our pop statement, right? So I think we should do the printing, but I'm too lazy, so I'm going to just print it here. Okay, very good. With that, let's run it. Oh, Index out of range. So what happened there? Well, we did not cover in our plan our edge case when there's nothing in the when there's nothing in our stack, right? So okay, so we do need to say if self stack is greater length is not 0, then we do this. Otherwise, we just straight up append x because there's nothing in it, so we just append x and x. Of course, we do need to append a tuple, and the question is this a tuple? This is a tuple. So, okay, very good. Yes, we do need to cover the issue of the edge case, but let's just run through the happy case first, and then we'll deal with that. So let's take a look at this item. So apparently the problem is that we have a tuple here, and we're comparing it against a int. And so we cannot do that. But I was pretty sure I'm picking up the first value. So I don't know what that's about. I see. Okay, this is the problem with combining lines of code. It's because everything's all mushy, mixed up. So max, let's just call max value. That way it looks cleaner and we will be able to decipher what the heck's going on here. Okay, so with that, we can basically add the right value. Okay, so basically we have our first item, we pushed the 2, we found the max. We find the max, and that's going to be a 2, right? Let's do a format. Well, let's do a string interpolation where we say find max, and then we have our code in here. I don't recall how to do that. I think it's printf, like that. Let's just find out. I think it's called an f string, exactly. And then yeah, that's how you do it. Yes. So let's run it. So we do a find max. There's the f find max, and there is the current value. We pop, and we pop the current value. So for some reason, our max is still 6. That's not right. So let's print out our self.stack, see what's going on here, because that's not what we intend. Okay, so it seems to me, oh, I see. So we inserted our item twice. That was the problem. Perfect. And so now we have the solution. I wonder why there were so many mistakes. I think it might be because this was not enough information. I think that was good, but I did not, because we had so many functions and we did not define the functions to begin with. We had so many errors that, but those errors should be worked out through the use of the code anyways. But I think having a nice plan which would show off your planning skills and remove that part of the issue, like of debugging so very often. So lastly, we do need to handle the edge case of popping like an empty stack. So let's try to pop an empty stack and let's see what sort of error that we get, and let's fix that. So let's run. As you can see, we have a popping from an empty list. So we just need to do if length stack, basically not length stack, then just return none. Run. Okay, so nothing is done. Or we could assert or do something, but nothing is popped. Okay, so it's all good. There's nothing to pop. I think that's a okay function for us. That's what we decided, and that's what we're going to do. And the rest of the code works properly, and that means that we have completed the problem. So let's remove the print statements. And we have completed this problem. So now let's do evaluate. To evaluate the problem, we looked at how we inserted each item. Let's just do it for each function. That way we don't make the same mistake that we've done for our plan, because we forgot to do this for each particular function, and that's why we ended up with so many errors. So let's push. So pushing would cost O of 1 because we just pushed directly into our stack. Let's check out, well, let's clean up this review code so that, well, I mean, let's just keep it there. But it is preventing me from showing off the push, and we have the pop. That's O of 1 as well. We just pop from the top. And then we have the find max. That is O of 1 time. And so all of these are O of 1 time. And of course, we're using O of n space because we're storing everything. So with that, we have completed the problem. If you enjoyed this video, like and subscribe. If you want more videos, check the link in the description below. And I will see you in the next one.